Hello and welcome. My name is Charles Ferlin. I'm the Vice President and General Manager of Edge Computing at Lenovo. I'm here joined with Oscar Palaros from Cellnex, at least virtually joined from Barcelona. And we're going to talk to you about the insight that you can generate from the data created at the edge of your infrastructure. So let's start with what is edge computing. The simplest definition would say that it's computing capabilities outside of the data center, closer to where the data is actually created, closer to where the users are actually using that data. So that could be your branch office, that could be a retail store, that could be a manufacturing plant where you have computing capabilities controlling the quality of the objects being produced. Or that could be in the middle of the ocean on an oil rig somewhere where you have computing capabilities to control the drilling that is happening and the overall security parameters of the oil rig itself. So edge computing is compute capabilities outside of the data centers, and it's a tremendous trend in our industry. Actually, Gartner's predicted by 2025, 75% of the data that enterprises are creating is going to be compute somewhere directly at the edge. So why is edge computing so important then? Simply put, it introduces new use cases that we could not do otherwise. What I mean, take the example of a campus or a large venue that wants to count the number of people entering and leaving their facilities. Well, they can display cameras all over the campus to film the people coming in and out, but if you have to bring all of this high definition video feeds to a centralized location for processing, the amount of bandwidth that is used to do this is simply insane. In most of the case, impossible, or if possible, economically unachievable or unreasonable, right? So we need to introduce edge computing directly on the campus so that the computer there, the computing capability, can actually start counting the people entering and leaving the campus and providing the final count at the end of the day. Just that insight is the minimal data. It could be about getting much faster insight to that data. Imagine a scenario where you're searching in a smart city use case for an actual license plate number. If you have to gather all of this information into a central location and have a huge computer computing and processing the video feeds, by the time you're able to identify that license plate number, that car might have moved on and is somewhere very far away. So the ability to have that compute capability directly at the street corner, for example, or directly in multiple locations in the city allows you to compute that image, extract the license plate, and take an action right then and there. Another use case that I like to think about is about augmented reality. When you have an application on your phone and you're pointing at a building in the city and there's an overlay of architectural information pushed down to your phone, the user experience is often less than optimal because there's a delay. When we point at the building and we move our phone, there's a slight delay, and that it makes the user experience pretty annoying, because the data is processed in hundreds or thousands of kilometers away in a data center somewhere. What we're doing instead is introducing edge computing in street cabinets all over the city so that when you're pointing your camera at a building, the data is processed a few meters away in a street cabinet and you get an optimal user experience. That obviously introduces a lot of new challenges. You need to have purposely built servers or edge servers that are able to operate in very harsh environment. They need to be able to operate in very cold, very hot temperature range. They need to have a high level of humidity, operate in a high level of humidity, or resist a lot of shock and vibration, or operate in a very dusty environment. So obviously you need to have a purposely built, ruggedized edge computer. That being said, by having the devices outside of the secure perimeter of the data center also introduces a set of challenges related to security. What if the device is stolen? What if the data is compromised that has sensitive user information on it? How do you protect that? And finally, another challenge not to be underestimated is that most of our expertise and tooling allows us to manage hundreds or thousands of servers in data centers in a few different locations. Now you're flipping this around and say, well, I have a few servers in hundreds or thousands of locations in a city, in a state, or in a country, or stores all over the world. How do you effectively deploy and manage those resources that are distributed all over the world? It becomes a real challenge. So to address those challenges, Lenovo has a pretty unique value proposition because it's really the coming together of our three main business groups to build our edge computing portfolio. First of all, the PC divisions, the laptops that we use every day, that we carry in our bag, that we unfortunately drop from time to time, that we spill water, and they still work perfectly for years. So the ability to build a very compact, very ruggedized devices that we can produce at scale is something that we learned from our PC division. When we're looking at our mobility group, most of the time these servers are in areas, these edge computer servers are in areas where you can't physically connect them to a network. You need to rely on wireless technologies to connect them. Well, Motorola or mobility group, MBG, has produced high effective communication device in phones and has the know-how and decades of know-how on producing high efficient communication devices in a very small, very compact form factor. And finally, the data center group, which is basically optimizing and increasing the performance and reliability of highly scalable computing devices. So it's really these three divisions coming together to create our edge computing portfolio. When we're looking at edge portfolio, Lenovo has a full breadth of that, a full wide portfolio range. From the tablets that we can use in the factories, to very ruggedized smart devices, to smart computer or edge servers, all the way to data center and server and storage. So we have really a portfolio that scales from the cloud all the way to the edge. With that, instead of talking about theoretical example, I would like to invite Oscar from Cellnex to share some of the live use cases that they have enabled using Lenovo technology. Oscar?
Thanks, Charles. Thanks for the introduction. I think it was very clear from your explanation what the edge computing is. And because of Charles' exposure, you will understand why this partnership with Cellnex. First of all, who's Cellnex? Cellnex in Europe, it's a infrastructure manager, neutral infrastructure manager, mostly for mobile operators. We are managing across Europe 60,000 mobile sites, and we are being a very active actor in the 5G deployment. Not only for the radio access, which is a relevant part, also with the densification with DAS and small cells, but also with the fiber to get the backhauling of those towers, since many data will be transported to the core of the network. And of course, if you consider these 60,000 towers, you will understand why this is relevant to the edge computing, because we can co-locate this data processing next to the radio cell. And because of that, we are getting lower latency, lower backhauling cost, and we are getting much more bandwidth for the end user. And these are the principles of this edge computing. And this will be placed in a distributed way. So it's very disseminated as much as different cell towers exist. So that's the reason mostly why we decided to partner with Lenovo and to define a joint architecture to deploy these use cases in the different industries. Now we will see some of these use cases, and you will understand much better the application of this technology. First one, and very nice, this is a mobility lab in Barcelona. This is a private racing facility to test commercial vehicles, cars for the automakers, so they can test everything related to the vehicle, to the infrastructure. We have deployed on a specific site, which is for a regular road, so no power. In that sense, the site is fully sustainable from the energy point of view, with a solar panel, with a windmill. But also to manage all this, we have an edge computing, as you can see on the right side picture with that cabinet. We have servers, real-time processing the activity of the road. When there's no activity, the equipment gets sleep. So just to reduce, to minimize the consumption, to maximize the life of this equipment. And this is all done with this power capacity, processing power capacity, on the site itself. We do not depend on a central core network. In fact, these are not linked with fiber anywhere. So these are autonomous, which are only talking with the cars in the road context. So for instance, if an ambulance approaches in a rescue service, all this is processed locally and it's broadcasted to the rest of the cars. So they are aware that an ambulance is approaching. This is a kind of solutions that requires these architectures. That means orchestrating many information from the IoT, capturing from sensors, and making these business logics, so taking decisions is something which happens at the edge of the cell tower. This is one use case. Let's see for another one, which is quite different to this one. Let's consider in the urban context, in a city like Barcelona. Cellnex is a headquarter company in Barcelona. Barcelona is somehow our flagship city. We provide the smart platform across all the city. And as you know, in the city, there are many cabinets where controls are deployed for traffic lights, for signage, for control traffic. All these is potentially elements that may be integrated with edge computing solutions. So any information in a crossing will be managed into that crossing, informing the pedestrians if they can cross, informing the cars if they need to brake or to accelerate because another or stop because another car is approaching, whatever. So think about how many potential cases can be deployed with that. And not only on the traffic management and the mobility, but think also about education, for instance. Can we provide a remote classroom with an hologram so all this information of the teacher can be spread anywhere in the world with these technologies, and this processing is done just nearby the classroom? This is one example that we are also testing in Barcelona. So these 5G use cases, we are using the city of Barcelona as a laboratory to later on scale up with the more robust cases that commercially can be fully developed also together with Lenovo. And another use cases that could be interesting for you to know also, it's very much related to the entertainment world. Imagine you are a spectator. This is a reality. We tested that service a year ago in a concert in Barcelona with Black Eyed Peas, where we provided a 360 camera on the stage near the singers, and we provided that image in a virtual way to the spectators that were listening live the concert. So their experience was like being nearby his favorite singer at the same time that they were listening real time the music. Can you imagine the same experience in in a stadium for soccer? Just before your favorite player comes into the pitch, you are nearby him in the dressing room tunnel, and you can even touch his shoulder and tell him good luck in the match. This is the kind of things that 5G will deliver as much more enhanced and rich experience. Some other cases would be on the enterprise world, which is very, very relevant. So even considering private networks. Private networks mean dedicated resource for connectivity, for critical mission, for operations, for privacy reasons. For that reason, in Cellnex, we acquired recently Edgecom, which is a Finnish company, the number one at European level, with already experience to deploy more than 30 networks in the enterprise, harbors, airports, minery, refineries, thermonuclear plants. So this is a brand new practice with many, many use cases that will need edge computing. So the example that Charles was explaining about reading the license plates in a context like a harbor, or maybe the ID numbers from the containers in the logistics industry, all these being real-time managed, so you get the response immediately, needs edge computing. Otherwise, there's no way. A huge amount of backhauling, a huge amount of cost also to manage those use cases. So these are examples. This is not, let's say, academical examples. All they exist are realities, although we are all aware that we are just in the first very initial ramp up of this new practice. So Charles, back to you. Thanks.
Again, it's a pleasure to be doing these use cases with Cellnex. The final use cases I want to introduce is regarding smart retail. In last year alone, in the US, $61 billion went missing by either theft or people mishandling the automatic checkout process. So by introducing cameras to film the exit of the store, and by introducing edge computing, we now have the ability with specialized software to monitor the situation, and if we realize that the object has been mishandled at the self-checkout, notify the local staff in real time and ask them to take a corrective action here. So very important, because you could not do this from a centralized location. The bandwidth requirement, the time to process this would be simply too long. You need to capture the data right at the edge, process it, and return insightful information right away. So I've talked about edge computing in the portfolio that Lenovo has to offer, obviously we have a portfolio from edge to the cloud. It's ruggedized, compact, ready to go. But we also define 3 key attributes that makes the edge computing experience a success for our customers. The first one is the ease of deployment. You do not want to send a technician to each site to turn the system on. So we developed an application that allows you to use your phone to securely authenticate the servers and make sure that this is the right person using the right server at the right location, at the right edge location. From that point on, we use Lenovo Open Cloud Automation to actually orchestrate all of the various tasks to configure the hardware, configure the operating system, configure the network, and configure the cloud layer so that the system is ready to be used within minutes, entirely automatically, without any human intervention, and all from a remote site. I talked a lot about security and how important it is. So sure, we designed our servers, our edge computing servers, to have special screws and have bezels to protect it so that they're hard to steal. But even we went a step further and used fully encrypted hard disk, and we put motion and tampering detectors inside the server. So if somebody tries to open the server or move that physical server from its original location, these detectors are triggered and the encryption keys of the hard disk are automatically deleted, making the device useless to anybody who has it at that point. We also introduced a lot of thought and leadership around how do we manage this remotely. You do not want to go to each and single site to monitor and configure these servers, but you need to manage this from a remote location. So we installed a small modem that a wireless communication device inside our edge computing servers so that you're able from anywhere in the world to dial in and you can turn it on, turn it off. You can do all the administration you want as if you were physically in front of the server without having to leave the comfort of your home. So in conclusion, if you're really looking at distributing or deploying edge computing capabilities in your branch office, in your manufacturing, in your stores, if really data security is something that is important now that you have left the secure perimeter of the data center, or if you're planning to use AI applications to get insights from some of your data that you're generating at the edge, I really encourage you to have a conversation with Lenovo or one of our partners about our edge computing technology. With that, I would like to thank Oscar once more and Cellnex for the great partnership, and I would like to thank you for listening to this video. Thank you very much.